Hey guys, Mr. Catlin here, gearing up for your homework. First page, lesson 8. This first page has a lot on it with some couple of tough problems. So let's jump in. If you need some help on it, you can come here and watch these videos. The number line can represent positions that are north and south of a truck stop on a highway. So for this particular problem, since it's north and south, I'm going to draw a vertical number line to help walk myself through this one. Okay, north and south is up and down on a map. That makes sense. And it says decide whether you want positive positions to be north or south. I'm going to make positives to be north and negatives to be south of a truck stop. So here at 0, we have the truck stop on the highway. All right, and let's see what happens here. We're going to plot the following positions on the number line. So we got our truck stop at 0. North is positive. South is negative. 5 miles north of the truck stop would be, let's do 1, 2, 3, 4, 5. This would be 5 miles north. And we plot that here. We got our truck stop here. And then 3.5 miles south. So 1, 2, 3, 4. Here's 3.5. That would have been 5, negative 5. And so this would have been 3 negative or 3.5 miles south. So there we go. Plotted it. That's pretty easy. That one's not too bad. All right, let's go on to number 2. How could you distinguish between traveling west at 5 miles per hour and traveling east at 5 miles per hour without using the words east and west? You could say that 5 equals 5 miles per hour east. And to show that you're going in the complete opposite direction, you could say that 5's opposite, negative 5, equals 5 miles per hour heading west. We've been doing that on our camera examples with the cars on the highway. This next one, we've got 4 people cycling, and we're going to be plotting their finishing points on a number line. So I'm going to sketch a number line for this one. I'll do this one in blue. So I've got my number line here. And on my number line, let's see what kind of numbers I'm dealing with here. 5 meters per second, and this is after 5 seconds. So all of these are going to get multiplied by 5. So the biggest one I'll have is 30. So I need to make sure that I get 30 covered. So let's go 30 in each direction, positive and negative. And this would be negative 15, positive 15, and then 5 and 10, 20, 25. Same over here. Okay. Diego. So let's start with Lynn. Sorry. So Lynn, I'm going to do Lynn in red. Cycles at 5 meters per second. It's positive. So I'm going to skip count by 5s. These are marked off by 5, so that works pretty good. 5 meters per second for 5 seconds. So 1 second, 2 second, 3 second, 4 second, 5 seconds. This would be Lynn right here at positive 25. And then for Diego is going to the left. We can see that because of the negative. Skip counting by 4 for 5 seconds. Now, if we did that, we could go back 4 or 5 times, which is negative 20. So 5, 10, 15, 20. This is where Diego is landing. Diego at negative 20. And let's do a couple more people. We got Elena, do her in green. She's doing 3 meters per second, 5 times 3, because we're doing 5 seconds. 5 times 3, she would land here at 15. And we go to the right because she's positive. So this is Elena. She ends up at positive 15. And then the last person we're going to do is Noah. Noah will have in blue. He's going west. He's going left on the number line, 6 per second. And we're doing 5 seconds. So 6 times 5 would land Noah over here at negative 30. There we go. We plotted them all on a number line. Pretty easy there. And then on the next section here, we're just doing some basic addition and subtraction with decimals and fractions, a little practice. So we do not have to add the opposite over here because they're already addition problems. But we're going to subtract their absolute values on this first one because their signs are different. One is positive and one is negative. We can only follow those rules if it's an addition problem. Those rules aren't going to work over here until after we change that. So I'll make this 15, make this 12, 6, 8. Difference of 7 there. And the winner of the absolute value battle is the positive. So the first problem there is 7.8. The next one that I'll do is the negative 9.2 plus negative 7. It's a plus problem, so no need to change any signs or do anything. We just follow our rules. Same signs means we're going to add their absolute values together. Don't forget to line up decimal points for this kind of problem. So 16.2. And the absolute value, they're both on the same team, negative, and so they win the sign of negative 16.2 for that one. And then, of course, this is the first one. All right, let's do these other two over here to the side. Before we can follow those rules for these last two, we have to do something that we learned last week, which some of us are struggling with, is we have to change this subtraction into an addition problem. So we're going to add, change it to a plus. But if we're going to make it plus, the second number has to be made into its opposite. So this is really 2/5 plus negative 3/5. And since the signs are different, we're going to find their difference. So we have to do 3/5 minus 2/5, and that is 1/5. And then we look to see who has greater absolute value, 2/5 or negative 3/5. Negative 3/5 is further from 0, so it wins the sign, and that's why we get negative 1/5. That's the first problem. Second one's a little bit more intense because you got mixed numbers and unlike denominators, so we're going to have to do a little more work. But we still need to make it into addition of the second number's opposite. So you can do that with just some quick little drawings of plus signs. And when you look at this problem now, it's addition, and one's negative and one's positive. So there's a battle between these two numbers, and we need to find their difference. So I'll take the number that has greater absolute value, write it on top, and we're going to subtract 1 1/4. The problem with this setup is our denominators. We need to rewrite this where they both have 8 on the bottom because 8 and 4 are common factors, or common multiples. So we need to change this from 1/4 to 2/8 because that is its equivalent, times 2 times 2, no change on the top necessary. And then we can subtract. 3/8 minus 2/8 is 1/8, and 4 minus 1 is 3. And the sign goes to the negative team because they have 4 is further away from 0 than 1 is. So this is actually a negative 3 1/8. And that's number 3. All right, so let's go to the next problem here. We have about this watermelon. All right, this one is kind of tough. It took me a second to wrap my brain around it because I was wanting to use this number. This is kind of a distracting number at the beginning, and you have to use it at the end to get the answer. But this shopper goes and buys a watermelon, napkins, and paper plates. So they buy 3 things. But in their state, they only get taxed on food. So they're only taxing the napkins and the paper plates. So the watermelon is kind of out of the picture at the beginning. And we have to focus on what's getting taxed. And what's getting taxed is the paper plates and the napkins. So if you thought of this as a double number line, you would have drawn a double number line with your 0 and your 100 like we always do. But in this case, you would think the 825 would go there, and that's what I was thinking at first. But not with the information they give us. They tell us 5%. So we know that 5%, which is way down here, they said when they taxed the 5% on the food, then that turned out to be 19 cents. Okay, or 0.19. And since that was 5%, we were really trying to find out what was the price of the napkins and the paper plates. So the 100% here in this particular case are the plates and napkins. And we're just kind of ignoring the watermelons at the beginning. If you were going to make a table for this, if you like tables better, you would have had percent value. Your 100%, we didn't know. We didn't know how much the paper plates and the napkins cost to start. But we do know that 5% of them being taxed cost us 19 cents. So the constant of proportionality is real weird here. When I divided 19 and 5, my constant was 0.038. So it has a kind of an unusual constant of proportionality. You can find it that way. 38 thousandths, and that will multiply by 100 and give you a value, just move your decimal over twice, of $3.80. So the price of the plates and the napkins was $3.80. And since the watermelon was not taxed, and this is before tax, the $8.25, you know that the $3.80 from your plates and napkins plus your watermelon, which right now is a mystery, equals your $8.25. So to find the answer of the question mark, you just had to subtract $8.25 and $3.80 and find out what their difference was. And so you had to do a little borrowing here. Change this to 12, then 11. Oh, no, it's just a 12. Sorry. Change that because the 5 doesn't need it, right? 5 minus 0 is 5. 12 minus 8 is 4. And 6 minus 3 is, I'm sorry, that should be a 7. My bad. Is 4. So $4.45. The watermelon costs $4.45. The paper plates and the napkins cost $3.80. You're going to get taxed 19 cents, which will add 19 to that. So you'll have a total of $8.44. But this is how much the watermelon costs, $4.45. And that is the end of the first page. First page was a doozy this week, so I thought I'd post it a little early.